Okay, guys. Lesson 8. Let's get it up there. This is some problem solving using quadratics. So a lot of this lesson, you guys, is going to be done on the graphing calculator. So make sure you guys have a graphing calculator, and if you don't have a graphing calculator, you might want to cozy up to a neighbor. You will absolutely need a graph. I don't have any on me. You will absolutely need a graphing calculator for this test, or else you're basically forfeiting marks. Okay, so on the top here, the book is just offering you a algorithm for finding max and min values, okay, which I've already shown you, and I'll show you again during the lesson. So this is gonna happen on your test as well as your homework. You're going to be given a quadratic equation, and then you're going to be asked to interpret the results. So this one here says the height h, which is the y coordinate, in meters above the ground of a projectile at any time t in seconds after the launch can be defined by this equation here. So right now you're going to enter that into the calculator. Can somebody read it out to me? Negative 4x squared plus 48x plus 3. Okay, now before we jump into the window or anything, what I would recommend is that you go check out the table. So second graph. This is going to give you an idea of what this thing looks like. So basically what I do is I look around 0. See how x going left and then x going right? Above 0 and below 0? See, look how small those values are getting. And then look at how large these values are getting. And then they go down again. So there's probably some maximum value around 147. Do you guys see that? And then it basically just, after that, it just gets smaller and smaller and smaller and smaller. And then if you go this way, it's just getting smaller and smaller and smaller and smaller and smaller. Okay? So basically all I need my window to see, like negative 10 to 10 on x is fine. And then how much y did I need? About 147? So I'm going to go to 200 just to give myself some room. And I'll just keep some symmetry. I'll go down by negative 200. So the y min and the y max is the lower part of the graph and the upper part of the graph. Okay, then I hit graph. And there it is. Okay, so what do you see? Do you think I need a little bit more y values? Or, pardon me, a little bit more x values? Yeah. It's x max. Maybe I'll just change this to like 30 or something. And there it is. Okay, so getting used to your window is a skill that you need to know. And I always tell students, just look at the table. And then just go up and down around 0. Like, what's happening around 0? And then you can figure out what this thing is going to look like. Okay? Now, let's go back to what the book wants us to do. So it says sketch, and then find the height, find the max height, how many seconds. Okay? Okay, so let's do part B. Find the height of the projectile 3 seconds after the launch. So right here, on this 3 seconds, can you guys just put x equals 3? Okay, and then how do you punch in an x value on this calculator? Second trace, and number 1 value. Then you can type in x3. Okay? Okay, for the sketch, you can see that the y-intercept is 3, so it's not going to be right at the origin. It's 3 there. and then it goes like this. Okay, and then for number or letter B says what happens when t is 3, or in other words, when is x 3? Okay, so this gave us a y value. What was it? 111. So you had this point over here, 3 comma 111. Okay, and then we used number 1 value. That was the calculator button that we used. And all your calculator buttons are going to be found in the second trace menu. Everything's in second trace. So now we need the maximum height, and then how many seconds to reach that maximum height. So like in, if I was doing this question in like a physics class, then we would understand what this -4 means and what this 3 means. This is like an initial displacement, and then this is like an initial velocity, but we don't have to know any of that. In here we're just trying to model this mathematical equation graphically, and we want to know the maximum height and how long it takes to get there. So second trace, and because the graph opens down, the vertex is a maximum. So click maximum. And then we just have to do this left bound, right bound procedure. So just make sure your cursor is to the left of the maximum. You can see the maximum's up there in at the top. So I'm on the left, I can hit enter. Now as long as I go to the right of it, now where it says right bound, anywhere to the right of it, hit enter. And then just hit enter again. And you get the value. Now if you have an older calculator like mine, you might have some decimal craziness. Ignore it. And the point is 6 comma 147. So in fact the table gave it to us. That's not always going to happen. The maximum might not always occur at an integer value. The table only gives you integer values, so like when x is 6, it was there. That won't always happen. So that's why we use the trace menu. I think it was number 4 maximum we used. And the maximum height is the y value, and it's in meters. And the time it takes to get there is the x value, and that was 6, and that's in seconds. So 6s. The height of the projectile at the launch, this is always asked. Always. So be prepared for this one. It's just asking for the y-intercept. So you guys know that that's the constant. And if you're having a major brain issue and that day you don't remember that, then you can always use number 1 value and then just use x equals 0. Because if you think about it, it's like, okay, what's the initial value at, like, what's the height when the time is 0? Like, you haven't started the experiment yet, so to speak, so that would be that value 3 right there. So if you go in your calculator, hit second function trace number 1 value, and then type in x equals 0, it'll pump out y equals 3, which is your constant over here. The constant you can see in the equation, I have it highlighted up there in the blue. Okay, and then it says determine when the projectile hit the ground. This is also a very, very common question. So when does it hit the ground? You're thinking about over here in purple, and it wants to the nearest tenth of a second, so it's saying when. So you want an x value. That's what you want. So when does it hit the ground? What kind of special point is down here? Yeah, the x-intercept. So how to find x-intercepts? Number 2 zeros. Good. So go into the calculator and now find x-intercept. Now this one always gives students a little bit of a headache because of the nature of this calculator and the way it's pixelated. So let me just show you another window setting that might mess you up. Imagine you couldn't see any negative y's. So let's just change y min to 0. So I only see the upper part. You know, some students might do this. And then when they go to do their intercept, the 0, the x-intercept, they lose the cursor. They don't know where the cursor is. Okay? So I always tell students, you know, maybe just give yourself a little bit of negative. Always just give yourself a little bit of negative so you can see where it crosses. So it's right there. I know it's going to cross in there. So second trace, hit 0. You still have this left-bound, right-bound procedure, so make sure you're to the left of it. And in this case, it means you're above 0. You can see the y value is positive here. You're left of the 0. And then when you go past the 0, watch what happens to the y value. Well, it's negative now. Well, as long as you're past 0, you're good. And then the calculator is going to search in this little region pointed out by these arrows. And then it says guess, and you hit enter again. And we get, again, really bizarre things happening on the calculator in like with these decimals. What does this mean right here? This little e. The physics students know what it is. Yeah, it's scientific notation. So this means times 10 to the negative 11. Times 10 to the negative 11, very, very small. Very, 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 very small. We're talking about a billionth. Smaller than a billionth. This is just the calculator's programming. It's just a bizarre thing. Ignore it. It's 0. This is 0. So then the value is 12 point, to the nearest tenth, 12.1. Okay, so back to the lesson. Okay, so when y is 0, x is 12.1 seconds. Okay, when the height is 0, that means it's hit the ground. The height is 0. Okay, is there anything left on that? This kind of question here is your prototypical 20-2 question in quadratics. In this class, you might get just a couple of these in a multiple choice. Okay? So, as long as you know how to use the calculator, you should be fine. In reality, like a really strong 20-1 student would be able to complete the square on this, find the max value by doing that on their own, and then finding the exact value of these intercepts, okay, using like the quad formula or completing the square. And then how many seconds after this, you plug in x equals 6 into this formula and you just solve it. So all this also can all be done by hand. And I challenge some of you to try that by hand. Okay, next one. This is going to show up in your written response. Exact question. Different numbers, of course. But no surprises. This is going to be there. It's the exact same solution as well. You just have to understand the solution and you'll be okay. Yeah, I see it right here. 2 marks. And then it's going to say use your calculator to solve it. So you'll get 1 mark for the setup, 1 mark for the calculator solution. Okay, and then there's going to be more questions like this in the multiple choice. Very, very similar, but we'll take those up in lesson 9, I believe. Yeah, lesson 9. There's going to be some stuff in lesson 9. This lesson is short. We're just got to do this one, and then you guys will be free. All right, so last season, this hockey club has 7,200 season ticket holders, and then the owner decides that he's going to raise the price of the package of season tickets for the new season to generate more cash. Okay, the existing cost is $1,400. So just some basic economics. Unit price times units equals revenue, obviously. It's like selling lemonade, right? If you sell 30 cups of lemonade and each cup is worth 25 cents, how much revenue are you bringing in to your company? It's just however many units times the unit price. That's what you're looking for here. So in this case, the existing costs of a package is $1,400. So this is your unit cost. And then it says, before raising the price of a package of season tickets, he hired a market research company to gather data on the proposed increase. The research company reported that for every $25 increase in price, about 100 season ticket holders would not renew their season ticket. Okay. So it says if the price increase is to be a multiple of 25, use the following procedure to determine what price would maximize the revenue from the season tickets. Okay. So you can write this. Y equals cost, which is just unit price, times the number. And that's your units. So it's just like Apple. If Apple sells 1 million phones and each phone is worth $600, okay? So just giving you an idea. So this cost times amount, okay? So what's the cost going to be? Well, it's going to be $1,400. That's the initial price. Plus, what are they increasing it by? 25. So they're doing a $25 increase for each X. So if X is 1, you add 25 once. If X is 2, you add 25 twice. If X is 3, you add 25 3 times. So for every increase in price, you'd write it like this. Okay, that's the cost. Let me highlight it for you. That's the cost. And then we're going to multiply by the number. So what happens? Normally they have how many? That's the units, 7,200 units. And every time they increase the price, people are going to be like, wow, I'm not into that, right? So they're going to drop out. So we're going to minus how many times each? Approximately 100 times each X. Okay, so that's the number of people. So if you can memorize that procedure, you'll be fine on these. There's 2 marks dedicated to this in the written response. So you can memorize that, you'll be fine. Okay, so what you're seeing here, binomial times a binomial with an x involved, what's going to happen here when you FOIL that out? You're going to get a negative x squared. So what this graph is going to look like, and I'll just sketch it, it's going to look like this. There's going to be some sweet spot. Some max value is going to exist. That's what you're looking for. Okay? So it says use the results of A to generate an expression. So we've already done that. You do not need to FOIL that out. Okay? You can, but you do not need to. Straight to the calculator. So 1,400 in a bracket plus 25x. Let's see how my memory is doing. Is that 7,200 minus 100x? Oh. And then just let it sit here. Do not press anything. Once you got it typed in, just let it sit there. One of the things I found in using this calculator is, like, especially if you're in a diploma or a unit test, if you hit graph and your window's not good, you're wasting about 10 seconds. You're sitting there, it's loading, you're getting mad. Nobody likes being mad during a test. So before I hit graph, because if I hit graph, it thinks. See, it's thinking up there? I'm sitting in a test getting mad, and then it's not there. So you just wasted like 4 or 5 seconds. And to some people, that matters. So I always hit second graph before I hit graph. Okay, and I see some really crazy stuff happening. I did not expect that. Do you guys see any real numbers here? What happened? Why is this so massive? This is insanity. So what happens if you see insanity? Oh, it finally fixed itself. So what happens if you see insanity like this? Hit zoom. In the zoom button, there is some leeway. Yeah, zoom fit is at the bottom. So zoom fit. In my experience, have not ever seen something like that. That's like one of the first times I've ever seen that. So in trouble, zoom, and then all the way to the bottom is zoom fit. And it gave it to us. Okay, so if you're in trouble with your window, zoom fit. Okay, second trace, let's find that maximum. Okay, and it says 8. I'm gonna have to write down that number. What is it? 10,240,000. See if I can remember that. $10,240,000. When X was 8. All right. So if they reduce the price 8 times, so how much are they going to reduce the price by? Reduce 25 times 8 is 200. So it's going to cost 1,200 now. And they're going to generate 10 million bucks in revenue. Well, do you own a hockey team? Okay, so we used zoom fit. I would just jot that in. And then it says determine the price of a package of season tickets which would generate the maximum revenue. So we found that when X was 8, Y was this 10,240,000. So it wants the price. So that's this green stuff. So 1,400 plus 25 times 8. So adding 200, so it's 1,600 bucks. For every increase in price. They did it 8 times 25. Then it says, how many season ticket holders would there be if this plan was implemented? So that's the number of people going. It's the purple highlight. So 7,200 minus 100 times 8. So it's just 7,200 minus 800, which is 6,400. Then it says, well, how much more revenue would be generated if the plan was implemented? How much more revenue? So the revenue, like we were saying up at the top, is the Y coordinate. So for the original, what was it for the original? What's the original price? 1,400 multiplied by 7,200, and then the new one, 1,600 times 6,400. And the two revenues are 10,080,000 and 10,240,000. 0.000. Okay, subtract the bigger number from the smaller number, and the increase is 160,000. Okay, so the assignment is not too long. There's only 5 questions, so if there was one that you would want to omit, I would omit 4. But number 1 and number 3, I strongly suggest. And if you guys want to challenge yourself to do 2 and 5, that would be great. Yeah, 5. Yeah, I would do 5 as well, with a big star on 5, because there's money involved. Yeah, Luigi in Alberta there, the Italian immigrant. Okay, so I would say 1, 2, 3, and 5.